to be doing the 2022 AIME 1 problem 10, which is 3 spheres with radii 11, 13, and 19 are mutually externally tangent to each other. So when we find AC, so we can see that a plane intersects a sphere in 3 congruent circles centered at A, B, and C respectively, and the central spheres all lies on the same side of the plane. So suppose that AB squared is equal to 560, and we want to find AC squared. So first we can try to take a cross section at AB, right? Because if we have a 3D geo, that will be really hard to draw this diagram out, and it'll be really hard to deal with it. So we can turn this into a 2D geo by taking cross section. So let's try to draw the two spheres. We have a sphere over here, and we also have a sphere that's similarly large. So we have these two spheres. So it says that if we have a plane that's cut through the two spheres, then we can draw a plane that goes like this, right? So these two circles, which is the portion that was cut by the plane, will be equal. So let this be midpoint, then this thing would be R. So let's just say this is R, and this is essentially equivalent. So basically try to remember this information because it'll be really, really significant. So the radii are equal, and we can try to connect the two centers. So this length is essentially 24, right? So this length is 24. So now we can also connect these two. So we can see that whenever we draw a line, draw the altitude from the center to the midpoint of the chord, then the altitude would always bisect the chord. So how is that going to help us is we can also drop an altitude from this center to this chord, to this altitude, to the altitude of the left. This is because we can see that the radii are different, right? So what is this length? So we can see this is 90 degrees. And these are all 9 degrees because we drop in altitude. Then this is essentially a rectangle. And we are given that this length over here is equal to square root of 560. And this is A, this is C. So now we also know that this length is 24. So what is the length, the little length over here? Let me just try to zoom this in. So what is this length over here? Then this length is essentially Pythagorean theorem. Square root, so we can take the square root. The length in the yellow is basically square root of 24 squared minus 560, which turns out to be square root of 16, which is 4. So this length over here is 4. But we don't actually need to use that too much, but we can try to connect these two lengths. So check this out. So if we connect these two, then since they're equal, then we can let this be R. So now let me just zoom this out again. You can see that the length over here, we can set up an equation. So we have 13 squared. 13 squares over here, 13 squares basically the radius. So 13 is the radius of the larger sphere. And then we subtract by, well, let's just call this B, M or whatever. And plus 4 squared, and that is equal to 11 squared minus m squared. So now we can just solve for m. So we have 8m plus 16, that's equal to 13 squared minus 11 squared. Right? So we can just solve the equation. So for 8m, so m is equal to 4. So m is basically also equal to 4. So now we can see that this length, the red length over here, is equal to 8. So we can just try to find the common radius of the 3 circles that was cutted. So how do we do that is we can just take the square root again. So common radius is equal to square root of 13 squared minus 8 squared, which is equal to square root of 105. So actually now we don't even need this cross section over here because we can just take the cross section of AC now. So now we're going to draw another 2 spheres. Okay, so we have a sphere over here and we also have a sphere over here. So let me just zoom this in. So we're going to connect the 2 centers again. Wait, sorry. So we can try to actually try to connect these 2. Yeah, so try to connect the 2 centers. And then we're also given that it's also cutted through a line, right? So these 2 radius are equal, so we can do the same thing as we did for the cross section of AB. Then we basically want to find this length. Well, AC is when this radius, the radius of the small one, is 11, and radius of large one is 19. So how we're going to do that is, this length is 30 because it's basically connecting the 2 centers. And we also know that R is equal to the square root of 105, right? So this is R. So now we can just find this length over here. Well, how do you find this length? Is we can do the Pythagorean theorem. So first we kind of want to try to find this length. So how we're going to find that is we're essentially just going to break out Pythagorean theorem. Have square root of 19 squared minus 105, which is square root of 256, which is essentially 16. So we know that the red portion, we just call this, well, let's just call this L, then L is just equal to 16. And we also want to know the length over here. Just call this M. So M is equal to the square root of 11 squared minus 105, which is equal to 4. So the black length over here is just the difference between L and M. So now we're almost done with it. So the length we desired, AC squared, just equal to 30 squared minus 16 minus 4 squared. Do 30 squared minus 12 squared. Do 30 plus 12 times 30 minus 12. Equal to 42 times 18. And that, after calculation, gives us 756 as our final answer. Thank you for watching. Hope you enjoyed. And if you have any questions, don't forget to ask in the comment section.